Hi friends, we are going to discuss about the analog input-output interface using Arduino. For the analog input, we have a 10 kilo ohm potentiometer connected to the 5 volt source and its variable pin is connected to the analog channel A0. And for the analog output, we have an LED connected to the PWM capable output digital pin number 9. The same thing was simulated using a TinkerCAD. You can see the 10 kilo ohm potentiometer is connected to the analog channel A0 and the LED is connected to the PWM capable digital pin number 9. So this is simulated using the TinkerCAD. Now we are going to discuss about the Arduino program. Look at here, the LED pin is connected to the pin number 9, which is PWM capable. We had declared two integer variable LED value and part value initialized to 0. So in the setup, we had initialized the digital pin number 9 as output and the serial to begin with the baud rate of 9600, and inside the loop, first we will read the analog value through the built-in analog read function through the analog channel A0, and the same was displayed in the serial monitor for the user notification. Since the analog to digital converter is a 10-bit ADC, we will have a maximum decimal value of 1023, but the Arduino microcontroller is only 8-bit microcontroller. Therefore, we have to map the value of 10-bit value into 8-bit value using the built-in map function. Map part value, 0 to 1023 is mapped to 0 to 255. And the same thing was written into the analog output, that is an LED connected to the pin number 9, which is PWM capable. The same thing is repeated for every 10 milliseconds. Now we are going to see the same thing through the simulator. Look at here, the code is available here and you can see the serial monitor in the bottom also. And look at here, the potentiometer is at minimum value and the analog value applied is 0, and you can see the same thing in the multimeter as 0.0 volt, and the LED is almost dead. It is in the minimal brightness conditions, and I am going to change the knob position of the potentiometer. You can see the increase in the input voltage applied to the channel A0. Suppose if I keep the voltage near to 1.25 volt, you can see the value will be somewhere around 250, and the LED is having 25% of its maximum brightness. And if I am going to continuously increasing the knob to the 50% of the maximum possible value, that is 2.5 volt, you can see the analog value in decimal will be around 511, and the brightness will be 50% of the maximum brightness will be possible. So look at here, it is somewhere around 511 and the voltage is 2.5 volt. And if I keep on increasing the input voltage applied to the analog channel, the brightness of the LED goes on increasing. You can look at here, if I keep the maximum value possible, that is 5 volt, which is equivalent to 1023 in decimal, you can see the LED is having the maximum brightness possible. And with this, you can understand that we were able to have a better understanding of the analog input interface and the analog output interface using the popular Arduino microcontroller environment. That's all from our side. All the very best.